Okay, welcome to the web and mobile track. Right, this is the second last session. Right, so for this talk, actually it's a workshop, so it's going to be longer, 55 minutes, and it will end at 4:05. So the title of the workshop, according to the schedule, is Recreate Old School Game of Typing Tutor, but it's actually using Pygame, right? So our presenter is actually Ms. Choong from a startup software consultant from National University of Singapore, right? So we'll pass the time quickly over to her. Thank you.
Hey, welcome. So this workshop is meant to be very fun. So if you have your laptop, you will be having fun. Okay? Be great. All right. So the Typing Tutor game, just a very quick introduction what the game looks like. It's just words falling down from the screen, and you have to type the words accurately, get it off the screen before it hits the bottom, which is where your city is. And it hits the bottom, it will destroy the city. Right? So very simple. Okay. So what do we need if you want to recreate this Typing Tutor game? It's a very old school arcade game, right? So all we need is just Pygame, know how it runs, and just create the city line. That's it for this workshop. We won't be going through the details such as scraping of the words for the game, all those things we won't be going through here, or leveling, or even adding sounds or animation. Well, we will have some animation, but those you can actually find out from the website if you are interested yourself. And what I'm going through here today is actually all also on the website if you want to look for it. Okay, so first thing, of course, clone the repo, and then you can start. So this game, what do we have for this game? Of course, the user, right? And the user types. And if it types the following words correctly, it destroys the word. If it does not type the words correctly, the words destroy the city. Simple? If there's any questions, feel free. Raise your hands. Okay, so for this game, as long as you have cloned the repo, so I've already prepared all the workshop files. So this is kind of like a glossary of all the workshop files, the folders, sorry, workshop folders. So the source file, basically it has the full gameplay. And the workshop directory, just plain WS, it has the skeleton files. If you want to just have the skeleton files and try to create the game with your own typing own words, feel free to use that one. And then as we go along the workshop, basically we'll go through and say, okay, this is workshop 1, 3 files. You just compile that one, and then it would be for that workshop. Yep. Okay. Okay, so and basically you can see this is what we'll go through. We'll go through, okay, how to install Pygame, and then how to create events in the game, how to display the text on your game screen, the gameplay itself, the different objects that we put in, how to animate, how to detect the typing key presses, and of course, how we build our city line. Questions? Am I going too fast? No? All right. Okay, so I actually, the first time I did this workshop, about 5-6 years ago, it took me more than 3 hours because all the people was like just trying to type out, and we don't type that fast, right? Okay, so simple things. Pygame installation. All you need, seriously, just pip install Pygame. Have done that? All of you have done that, and give it a try. All you need to do is navigate to the source folder, run the game. Then you can figure out very quickly how it runs. Okay. Okay, I'll get back to you. So next. Okay, so now that we have installed Pygame, so next, okay, for the next step we have here is just to import the Pygame package and then initialize Pygame, and then that's our entry point. Seriously, for any Pygame out there, this is all you need, right? define the class, and run it. Right? And then next, we want to define our game display surface area. So this is basically where our game will be running. And we have gone with the size of 640 by 480, very standard console size. And then we set the game title. Right. This Pygame display set caption is where we set our game title. And then we just load it. That's the game surface that we have created with the title, and we just load it. So with this, next we want to set up the game loop. How does it look? All right. And then once we set the game loop, it's just it. We want to check for events. Very simple. We want to check for events. What are the inputs, the user inputs that's happening? Right. So that's the user events, and we want to detect whether or not the user pressed the red cross on the top of the screen to quit. And then we stop the running. We set the running flag, we stop the running. Simple. And that's it. If we execute the game from workshop 1, that's all we get. Version is not compatible. Anybody else on yeah, they're running on MacBooks as well. Yours are running fine? Yep. Yeah.
That's weird.
Yep. Yes.
Maybe actually closes workshop 1.
Yeah. Doesn't work for you? Did you make any changes? What's the error? You could run workshop 1?
Already, but what I need to change here?
No, you don't need to change anything. That's it. Okay. Sorry, because of time limitations, we'll just carry through. Just follow my description, and you can go home and give it a try yourselves. Right? Okay. So that's workshop 1. That's all you have for workshop 1. So, and then next, we go through to the game state. What are the game states? Every single game you have, you start the game, you play the game, game over. Very simple. Right? Start, play, game over. So we set up the states, and then we say, okay, just a space bar to run through the states. We just need to go from state 0, 1 to 2, right? We run through the states. So space bar to go over the different states, and that's it. So once we have set it up, and then we display the feedback of the state so that we know that, okay, yes, this is at what state. We just display the feedback. We put the surface area. We fill it up with black. And then we bleed the text. Right? Remember here, we put up the states already. So all we need here is to literally just render the text. We have the black color for the screen. Bleed is basically block transfer. You're transferring the image to the surface, the game surface, and then you flip it. Basically, you're updating the screen, refreshing the screen. Now we define our text, right? What text do we have? We have the start, playing, game over. Simple as that. And same here. What we do here, we draw the text, we prepare for the rectangle where we have our text. We just need to prepare the rectangle, the color of the text that I've defined as green above, and then we bleed it to the surface. Okay? And this is workshop 4. And then we add our text to display the different states. Right? Because we have already prepared our function, it will bleed perfectly. And then if you run workshop 4, that's what you get. Okay? Simple. Okay, next, workshop 5. What we do now is we actually go into the gameplay itself. So similar to game.py, So we have, what we have previously is just we have all the codes on game.py. Now we just prepare a new file called play.py. And inside play.py, we'll put in our gameplay itself. Right? So we prepare the fonts first. What are the fonts we want? So previously, we just put a big font on top of the center of the screen, 32. Now we have calculated, okay, now we want the font size 16. And then we just said, okay, now we have our gameplay, which is different from our starting screen. From the game.py, we go into play.py and out. That's it. Right? So now other than the key press, other than space bar, if you hit escape, that would mean game over. Okay? Now for our game, we want to differentiate the playing of the game from the start screen. The start screen is black. The game itself is blue screen. Right? We just draw the word playing for now. We are not going to do anything about it. We just put it on the top left coordinates, which is of course 0, 0 right there. And then we bleed the screen. Okay. Then from so from game.py, you want to import play.py, right? So we created the gameplay in play.py. So we import it, and then we execute it from game.py. So when we execute game.py, we will go through the states, and when the state goes to playing state, we go into game.py. Simple? And that's workshop 5 for you. Okay? All right. So now let's look at the game objects. What game objects we have? Not a lot, just the words. Right? So inside our our objects.py, what we do have to do? Initialize the words. The words that we use to be falling down from the screen. So here I've already prepared the words list for you. It's inside the resource folder. Basically scraped from the Gutenberg library. Basically the brown.txt is where all the words are. And inside basically we has all the words already. And then we just grab it from the resource folder, the word.txt. And then we strip it of all the unnecessary things just so that we tokenize. This is what we call tokenizing, right? We tokenize all the words so that we know that okay, each word is which of it. And then now we have our word list. We shuffle it up just for randomness. And next, we want to include these objects from play.py. Now our play includes objects, the game objects itself. And then we create a word.py so that we can have all the methods required to manipulate all the word objects. Simple manipulation that we need is, of course, getting the x and y of the word. So each word, when we create the word for the game object, we want to initialize it with an x and y. We randomize it for now, right? We just give them the limit of the randomization from the x-axis and sell the y-axis. Y-axis is, of course, always going to be the top, basically about 20 from the top. And maximum, it will fall. And then the x is basically the length of the screen, right? Minus the length of the word. To prepare for that. So it's easy to calculate the length of the word by multiplicating it with the size, the font size. Okay, so we know that the font width based on the Consular's board 16-point font is always 9. So you multiply it by 9 with the length of the word, you get the size, and then from there you calculate your max and mean of your randomization of your x-axis. And when you add word, that's where we get our x-axis. Okay? And then now we want to add the timer to add the word. So we don't want to add the word for every single computer cycle, right? We want to add the word in intervals. So we put a counter in there, right, to get the pi time get the ticks to make sure that, okay, once the timer has run out, then only we add another word. Then of course, once we add the word, we have to draw the word. So this is where we draw the word inside the render function. Right? We create a method of draw word already, right? And we want the word to be white color against a blue background. Then we draw it like so. Okay? Any questions? No? Okay, following. Okay. So next is animation. So most games have certain animations, right? So how do we control the animations? For here, I put the FPS of 25. That means the frame rate, frames per second of 25 frames per second. So it's pretty much okay for most situations. 25 is actually quite quick. And then, of course, we get the FPS of the CPU clock. And then we want the Y delta to be 1. So for every frame, we want it to move by 1 pixel down. And then we just add a tick. So we move it by 1 pixel down, right there, the Y delta. Okay, so the X doesn't move. We have already randomized the X, the location of the X, and then we just need to move it down. And then that's the move method that we add into the word.py, word.py. Now you need to set the boundary of Y. We know that we drop the word from the top of the screen, roughly 20 pixels, and then we want to say, okay, where is our city line? Let's set our city line to be around the height of 40 from the bottom of the screen. So all we need to do is minus the boundary. The boundary of Y we calculate is just the screen minus the 40, right? So once it hits, the word goes past the 40 Y-axis from the bottom. That means that, okay, it has destroyed a city, it gets to be destroyed as well. So that's the boundary of Y. It just moves from top to the bottom. And then we want to create a remove function. All we need to do here, what we do here is just we set a flag for remove. And once we have detected that is the word, there's a flag in the word that says that whether it's typed. If it's positive, means that the user have typed to which character on the word. If it's -1, means the user has typed correctly the word. So now remove the word. You want to destroy the word if the word has been typed correctly. -2 means that the user has not typed it correctly. It has moved past the boundary Y. So you still want to remove it, but the user hasn't typed it correctly. Okay? I think might be the other way around, whichever, so either -1 or -2. Okay, so now you have your animation. The words now move from the top of the screen down. Okay, next, city line, collision. So for all games, there is always collision. When you play a shooting game or whatever game, right, collision happens. That's where we want to detect the collision, that something has happened. Detected collision, we want to destroy something. So how do we detect how do we create the city line? This is how. So the city line we know is all on the bottom. It's just one line from the bottom. So we just randomly calculate the height of the block. We consider each city a block. At the bottom of the screen, you give it the block size of 10. We divide by 10, and we say that each 10 pixel is one block. And then we randomly give the height of the block. And then from the height of the block, we can calculate, okay, do we need a straight line here? Because if there's a difference in the height, we need a straight line. So it's very easy to draw the line. So this is the function that draws the city line, and the function to iterate through the different blocks at the bottom of the screen. The function to delete the blocks. This is just a negative, whether it's a -1 or a positive. The positive is, of course, the height of the block. -1 means that it's been destroyed, so don't draw anything. Right? And of course, to check game over. For the check game over, you just check that if all blocks is -1, means it's game over. Simple, right? Next, we have some helper objects. It's literally just the city iterator for us to get through all the blocks at the bottom of the screen. Right? And then, of course, we have to add the city line in object slot py, and to check for collision and check for game over from the object slot py. Okay? So we have created all the functions in the city.py. We are just adding it into our main game. Same thing for the play.py. Now we use the light blue color for the city line. So remember, our gameplay was dark blue. Our city is now light blue. And then we initialize our city itself. We render it, draw the city based on whether or not it's been destroyed or not. For each render literally means each frame, we have to redraw this. And for the add word, we also check whether the game is over before we add a new word. Okay? And here we just update game.py. That's it. So in game.py, we check for the available blocks. Here we just add a little bit of remembering basically add a little bit of difficulty to the game. So we don't just drop the words randomly. We check whether there is a city block below. There is a higher chance of appearing a word on top of a city block. That would increase the difficulty of the game and make it more interesting. Right? So that's why that we check for the available blocks before we do the randomization of the word. So it looks like this. So you've noticed that, okay, if there is no block, there is a lesser chance of us having a word here. Okay? All right. And of course, the score is very simple. We calculate the score by how many words we have typed. Each character is just 1. And then, and that's actually it for the game. Now we have about 30 minutes for you to play the game. So I'll come help you with your game. And for the rest, let's see if you can beat this high score. I played this on a mechanical keyboard, so for those, I think using Mac keyboards, you actually have an advantage. You most likely can get 400 over easily.